A good day to lecture. My name is Kyoichi Singh and my matrix number is 278061. Now I'm going to present on the second example of how to convert an algebraic expression into a binary tree. So this is the algebraic expression given. As we can see here, there's a lot of operators, a lot of brackets, a lot of numbers and variables. So how do we identify which will be on top of the whole tree? We do it by counting brackets and knowing which operator separates the numbers, variables, and the arguments. So one thing to take note here, operators will always be the parent. Sometimes they will be the offspring as well. But if there are numbers or variables with the operator combined together, the operators will always be the parent of the numbers and variables. So let's start by counting brackets. So every bracket will have a left and right, which is like a pair. So we count right here from the inner side of this argument. One left, one right, one left, one right, one left, and one left. As you can see, this operator separates a left bracket and a left bracket, which means this operator actually separates a left argument with a right argument right here. And this left bracket includes the whole expression in it. So we can ignore this bracket. So we can safely put this divide operator as the top of the tree. Next, we're going to start to branch out from this operator right here into the left argument. So as we can see here, the left argument has two operators. And how do you know which operator is the main one? We calculate brackets again. One bracket right here, left side, one bracket right here, right side. So we can know that this bracket contains this operator and this operator is contained by a bigger bracket, which is then proving that this operator separates 3, which is a number on the left, with an argument 1 minus x on the right. So multiply will be the parent of these two offsprings. Then we moved on to branch out the two offsprings, which is 3 and 1 minus x. So remember what I said earlier? The operator will always be the parent. If there is like 1 minus x, 1 is a number, x is the variable. So the operator will be the parent to 1, the offspring, and the x offspring. So next, we're going to go on to the right side of the expression. So how do we know which operator right here is the main operator that is going to branch out from the divide? We do it by counting brackets. One bracket right here, left, one right, one left, one right, one left, one right, one left, and one left. So we can see these two left contains a main operator right here, which is a multiply. So the multiply will be the main operator to the left argument and the right argument. And now we're going to proceed to break down the left argument into its operator, parent, and its offsprings. So as we can see here, there's 3 operators right here. However, this 2 operator is covered by brackets, which is contained by inner bracket of left, right, and this operator plus right here is contained by a bigger bracket that contains all of them, which makes this plus operator the main operator. So here we branch out from this secondary operator to a tertiary operator of plus and its offsprings of 4. And now we have another argument which has 2 operators. Now that the plus has been used as a parent, so we move on to the inner bracket, which is the minus that is separating the left number 7 and the right argument containing another operator. So the minus is going to be the parent to 7, and as we said earlier, the operator will always be the parent, which in this case y plus 2, so we write it as plus as the parent into its offsprings of y and 2. And then we're going to move on to the right argument right here, which only has 2 operators covered in brackets. So one left, one right, and then it's an operator right here. So we can safely say that this plus is an operator of the offspring 7 and the argument x divided by y. So we have 7 offspring right here. So we proceed to branch down to the other offspring, which has divide as the parent and into its offsprings of x and y. So now that you've seen the example, we're going to go on to the exercise. So right here, we have an exercise of x divided by y divided by x multiplied by y minus z minus 4 in a big bracket. So this is fairly easy compared to the previous one. Why do I say so? It's because this x divided by y is only covered in a pair of brackets, which makes it the left operator already. And we can know that this is the main operator separating this left and the right argument. So we can safely say in the beginning of the tree is a divide, and it branches down into x divided by y, with divide always the operator being the parent to its variables or numbers. So divide branches down to its offsprings again to x and y. And then let's look at the right operator. So how do we find the right operator? So we count brackets, 1, 1, left, right, 1 left, 1 right. And we can see this bracket actually separates itself with this operator in the middle, and another bracket separates its own argument as a whole. So we can see here that divide is obviously separating these 2 arguments. So divide will then be the parent of these 2 offsprings inside this big bracket, which is the multiply being the parent for x and 3, its offsprings x and 3, and the minus being the parent to z and 4. So z and 4. So that is all for my presentation. I would say that there are a few things to take note. Again, is that the operators will always be the parent. If there is numbers and variables left in an argument with an operator, the operator will always be the parent, and the number and variables will always be the offsprings. And whenever you face difficulties on how to calculate, how to separate them, or how to find the brackets, always start inwards of the big brackets, start in the inner ones, and then you just left, right, calculate the pairs to the outer ones, and then it will make things clearer for you. So with that, I end my presentation. Thank you.